Now we move to another Apache product for large-scale text data searching called Solr. Systems like Solr and its underlying text indexing engine are typically designed for search problems. So they would typically be part of a search engine. But before we talk about Solr or large-scale text, we need to first appreciate some fundamental challenges when it comes to storing, indexing, and matching text data. The basic challenge comes from the numerous ways in which a text string may vary, making it hard to define what a good match is. Let us show some of these challenges. Remember, in each case, we are asking whether the strings shown on either side of the double tilde sign should match. The first issue is about spelling variations and capitalization. The second issue relates to structured strings, where different parts of a string represent different kind of information. We have seen this before for file paths, URLs, and like in this case, product IDs. The problem is that the searcher may not always know the structure, or might drop or misposition the internal punctuations. The next problem is very common with proper nouns, which are represented in various ways, including dropping a part of the string, picking up only the initials. Now consider the last variation. Should B.H. Obama really match the full name? The next example is about frequently used synonyms. If the document has one of the synonyms, while the query uses another, should they match? Example 5 illustrates a very common problem. People use abbreviations all the time. If we look at text in social media and instant messaging, we see a much wider variety of abbreviations. How well should they match with the real correct version of the term? Now, problem 6 is a special case of problem 5. Many long nouns are shortened because we take the first initial letter of each significant word. We say significant because we drop words like of as shown here. This is called initialism. Just so you know, when an initialism can be said like a real word, it's called an acronym. Thus, IBM is an initialization, but NATO is an acronym. Now, problem 7 and problem 8 show two different situations where we first must decide what to do with the period sign. In the first case, we should not find a match because students and American are in two different sentences punctuated by a period sign. But in the second case, we should find a match because the period does not designate a sentence boundary. Lucene, the engine on which Solr is built, is effectively not a database, but a modern inverted index. What's an inverted index? Let's first define a vocabulary as a collection of terms, where a term may be a single word or it can be multiple words. It can be a singleton or it could be a collection of synonyms. Well, how would a search engine know what a term is? We'll revisit this question in a couple of slides. For now, let's just say that if we have a corpus of documents, we can extract most of the terms and construct a vocabulary for that collection. We can then define occurrence as a list containing all the information necessary for each term of the vocabulary. It would include information like which documents have the term, the positions in the document where the term occurs. We can then go on to compute the count of the term in the document and the corpus. Referring back to a previous module in this course, we can also compute the term frequency and inverse document frequency for the collection. An inverted index is essentially an index which, for every term, stores at least the ID of the document where the term occurs. Practically, other computed numbers or properties associated with the terms will also be included in the index. Solr is an open-source enterprise search platform. The heart of Solr is its search functionality, built for full text search. However, Solr provides much more than text search. It can take any structured document, even CSV files, which can be broken up into fields and can index each field separately. Full text indices for text columns are supplemented by indexes for other types of data, including numeric data, dates, geographic coordinates, and fields whose domains are limited to an enumerated set of values. Solr provides other facilities like faceted search and highlighting of terms that match a query. Now, if you're not familiar with the term faceted search, let's look at the screenshot from Amazon.com. I performed a search on the string Dell laptop. Consider the highlighted part of the image. Each laptop record carries a lot of attributes like the display size, the processor speed, the amount of memory, and so forth. These attributes can be put into bins like processor type has Intel i5, i7, etc. Faceted search essentially extracts the individual values of these fields and displays them back to the user, usually with a count of the number of records. We see this in the upper part of the marked portion, which says there are 5619 laptops but 411 tablets. These are called facets. If a user clicks on a facet, documents with only those values, that's just the tablets, will be presented back to the user. Now let's get back to the question of what a term is and how a search system should know it. Solr allows the system designer to specify how to parse a document by instructing how to tokenize a document and how to filter it. Tokenization is the process of breaking down the characters read. For example, one can break the stream at white spaces and get all the words as tokens. Then it can filter out the punctuation like the period, the apostrophe, and so on just to get the pure words. The code snippet on the right essentially achieves this. It uses a standard tokenizer that gets the words with immediate punctuation. The first filter removes the punctuations. The second filter turns everything into lowercase. And the third filter uses a synonym file to ensure that all the synonyms get the same token after ignoring the case. The last filter removes common English words like a and the. Well, a similar process would need to happen when we get the query string. It will also need to go through a tokenization and token filtering process. In the query analyzer example, there are 6 filters within the tokenizer. We use a pattern tokenizer which will remove the white spaces and periods and semicolon. The common grams filter creates tokens out of pairs of terms, and in doing so makes sure that words in the stop word file are used. So if we have the string the cat, the term the should not be ignored in this filter. Now the filters here are executed in order. After the common grams filter is already done, the next filter removes all the stop words in the file. The fifth filter makes sure that if the query is coming from a web form, all the HTML characters are stripped off. Finally, the remaining words are stemmed so that runs and running in the query would match the word run in the document. We'll end this section with a discussion on Solr queries, that is searches. We present a CSV file with 9 records and 7 attributes. We issue queries against the system by posing a web query. In these examples, we show some of the queries one can pose to the system. This will be covered in more detail during the hands-on session. Just notice that the Q equal to is the query and the FL is what you want back.